Hello and welcome to another episode of How to Do That. In this episode, we will actually be going through the first tutorial in the book. So this will be video 01. I've already done a tutorial video about the initial setup for the Arduino, so if you haven't seen that, please check that out first before viewing this tutorial. So in this tutorial, we will not actually be making a program with our Arduino Uno, but instead we'll just be experimenting with voltage, current, and resistance. So this board will only act as a power source for now. In the next tutorial, we should actually get to writing some programs. So first thing to do is gather our materials. So what we're going to do is we're going to use an LED and some switches. And by pressing these switches, we will control the LED lighting up. And we're going to do two different types of circuits. We're going to do a series circuit and a parallel circuit. If you don't know what those are, that's fine. We are going to go over those today. So let's go over our materials. So the first thing you need obviously is the board that we assembled in the last tutorial. You're going to need these jumper cables. These should be the only cables that look like this in your starter kit. It's just a red and black wire. They are not connected to each other. They are separate wires. You also need this assortment of different sized wires. You get anything from really small to fairly large wires. We're only going to use a few of these from this pack. You'll also need one LED. They look like this. It doesn't really matter which color you pick. I just picked blue. You will need two switches. They look like this. And finally, you will need a resistor, but not just any resistor. You'll need a 220 ohm resistor. And the way that you can tell how many ohms a resistor has is by looking at the color code on the resistor. If you want to learn more about resistor color codes, about how to tell actually how many ohms a resistor is, I have another video on the channel called Resistor Color Codes. So please watch that if you want to know how to look at any resistor and be able to tell how many ohms a resistor is, because that is actually very important for building circuits in the future. First, let's go into details about the various components. We'll do the LED, the switch, and the resistor. Starting with the LED, the first thing you should notice is that one wire is slightly longer than the other, and that is not by mistake. The longer wire will always plug into the positive side of your circuit. So an LED is actually a diode, which is something we'll get into in a later tutorial, but it is a light emitting diode, thus the name LED. And so this wire right here, the longer one, should always go on the positive side of your circuit in order for the LED to function. So just to touch briefly on what a diode is, it only allows electricity to flow in one direction. So that is why these wires are marked in the way that they are, because it actually does matter which side of your circuit to put your LED. Next up, we have switches. Now, the tutorial book just calls these a switch, but this is specifically a normally open switch. And what that means is that when there is no interaction on the switch, in other words, you haven't pressed it, the circuit is open. And an open circuit is one that is not complete, which means there will be no electrical flow through the wires. So this is a normally open switch, which means that you actually have to press this button here in order to close the circuit. And a closed circuit is a complete circuit, and that will allow electricity to flow. Further, with this particular type of switch, you'll notice, I don't know if you can see this very well on camera, let me try and pick this up here with my tweezers. There are legs coming out of one side, legs coming out of another side, but not the other two sides. Hope you can see that. And that actually matters, because the way that these type of switches work is that these legs on the side here are not connected. They are an open circuit. And these legs on this side are the same way. Whoops. These are also an open circuit. However, the two sets of legs from here to here, that is an already closed circuit. So in other words, if you connect a circuit through here and on the other side, whether that switch has been pressed or not, there will be electricity flow through those legs. Same thing on the other side. And lastly, we have the resistor. A A resistor works by controlling the flow of energy in a circuit by resisting it. And the reason that you need a resistor is that if you allow too much electrical flow through your circuit, going into certain components, you can actually fry those components. So it's very important to know the amount of resistance in your circuit. The way that it resists electrical flow is by taking the electrical energy that's passing through it and converting it to heat. So this little bulbous bit right here will actually get a bit hot while in use. Now, for all the resistors, I believe, for all the resistors that are supplied with your starter kit, you could, briefly touch them while in use and they're not going to hurt you. But there are other resistors out there that have a lot of wattage that they're dissipating. And if that is the case, they will get very, very hot to the point where they can actually burn you quite severely. So always be careful with resistors, which if they're carrying that much wattage anyway, you probably don't want to be risking touching this connection here and causing a short circuit through your finger anyway. While the resistor that I have is blue and it's 220 ohms, yours may not be the same way. Different kits actually have different colors and color codes of resistors. And when I refer to color code, by the way, I don't mean like the fact that this is a mostly blue resistor. I mean these little bands here. So if you don't know how to read resistor color codes, I highly, highly, highly recommend that you first view the other video on my channel here that is called Resistor Color Codes and learn how to read these before you try and select a resistor to use in this project. It's not as important for this tutorial necessarily, like it's still gonna work, but in especially later tutorials, you can actually damage your board by using the wrong resistors. So be sure to do that first. So before we start with our simple circuit, I do need to explain how breadboards, which is this white thing, works first. So underneath the plastic here, these holes are not all separated. They're actually all connected underneath in some way or another. So for instance, in this thin portion, because you'll notice if you look closely at your breadboard that they're almost divided into columns here. If you look at this thin portion, what's actually going on underneath is that all the holes in this first column here of holes are connected. And these holes in this second column of holes are all connected, but they are not connected to one another. Okay, so it's just this column and this column are connected. Same thing on the other side, on this thin section of your breadboard. You have all of these connected and all of these connected. Now for this middle portion, it actually goes the opposite way. It's the rows that are connected, but only up to this divider. So for instance, these are connected, and separately, these are connected, and separately, these are connected, and so forth. Same thing over here. These are connected, and separately, these are connected, and so forth. The holes on this side are in no way connected to the holes on this side. And the reason for this separator here, as we'll see, is that electronic components are spaced such that typically the spacing between legs, for instance, in a switch, will fit this gap perfectly. And that is what we are going to be taking advantage of to build our circuit. So let's begin by building a very simple circuit. It's just going to be one that uses the resistor, the LED, and one of the switches. And we're just going to use one of the switches right now to make sure that we understand how a breadboard works and how electricity flows. So the first thing to do is to bend your resistor. So when we pulled the resistor out, it's fairly straight. But obviously you can't fit both ends in there without bending it. So the safe way to bend it, most people just kind of bend right at, they just do it like that. And there's nothing wrong with that necessarily. But I prefer just to give myself a little bit more room. I like to hold it a little bit past, because I've also had these break off before, right at the right where it connects to the actual resistor. So I kind of give myself a little bit of room. I kind of hold it, pinch it between my fingers, and fold, kind of using my fingernail as my folder mechanism here. And I do the same thing on the other side. Don't worry about the actual spacing here, and you'll see why. So I'm going to place that connecting to my positive column here. I'm just going to pick this one right here, and then I'm going to place it connecting to one of the row holes. So as I'm pushing in, and you do have to give a little bit of force, you'll actually feel it press into your breadboard. And I'm just going to connect it to just one of these row holes here. Don't know if they have an official name, but that's what I'm going to call them. There it is. Did you hear it kind of click in there? And you'll actually feel it slide in to the metal inside there. So notice, I don't know if you can really see that in the camera, but notice that I predicted it was going to be this wide, but it ended up being a bit thinner of spacing needed. And it didn't matter. I just kind of forced the wires in there. It's not going to hurt anything. That's why I said the spacing doesn't matter that much. Now, I should note before we continue here that it is just good practice to not have your board plugged in while you are doing wiring. And the reason being is that we're not doing very complex things right now, so it's not horrible if you mess up with this right now, but it's still just good practice. If you don't have this plugged in, no matter what you do over here, and once we connect it into the board, nothing bad can happen. It's only when power is being run can things burn out. And as long as you're following closely with the tutorials, and if you're doing your own projects, you've calculated all of your currents and voltages correctly, you shouldn't ever have an issue. But even if you have calculated those things correctly, always have this unplugged while changing anything over here or over here, because that just helps you avoid, for instance, a short circuit, which could actually fry your board, and that is a bit of an expensive mistake to make. So please just don't have this plugged in while you're doing any wiring. Okay, so the resistor, as I've said before, is there to limit the amount of electrical energy that can go through the circuit. In this case, it's not necessarily for making sure the board doesn't burn out or something. It's actually to make sure that the LED does not get damaged. Now, for the currents and whatnot that we're working with, again, it's probably not that big of a deal, but it's always good practice to have at least one resistor in whatever circuit you're working with, just to prevent catastrophe, really. So the next thing we're going to put in our circuit is the only switch we'll be using for now. Now, again, it's very important to note which side the legs are coming out of the switch on. In our case, we want the side, either side, that has the legs coming out to be placed in such a way where, so here's the side with the legs coming out. The leg is going to be going in this hole right here, which is going to end up connecting to this resistor. Do you see how underneath the breadboard, all of these rows, or all of these holes in this row are going to be connected? So electricity is going to flow through this resistor, go through these holes, and then into this leg of the switch. So I'm going to press that down now. And recall that the leg between here and here is separated by this switch. The leg between here and here is not. It's a closed circuit, which means that electricity will flow. Because we don't have anything else on this side, electricity will not flow there. But if we were to connect a circuit over here, regardless of whether this switch is pushed or not, this side would actually be powered. So keep that in mind when using switches. In our case, we're wanting to actually power an LED by pushing this button, which means that we need to connect the LED on this leg, and we're going to do that now. So here's our LED, and if you remember, we said that the largest wire refers to the positive side of the circuit. How do we know what the positive side of our circuit is? Well, we've actually already defined the positive side of our circuit by plugging in our resistor into this positive terminal. Now, it really doesn't matter that this says positive and this says negative. We could have easily plugged the resistor into the negative, but then still plug the negative into our positive side of power. These are just to help you remember which side is what to your circuit. So I do recommend that you use these labels to your advantage. And in what we've done here, we've connected the resistor to the positive column here, so we know that this is the positive side of the circuit. So if we follow along where the circuit goes, And I'm going to put my LED here because the leg of the switch is here, and I want it to be connected to that leg, so I'm going to put my positive side of my LED there. There we go, just like so. So now I know, since this is my longest leg on this side, that is connected to my positive side of the circuit. And then we're actually now going to take the short side of the LED, or the negative side, and we're going to connect that up to the negative column here. And we're going to need to do that with one of these wires. So this is one of the wires that come in this bag. And you'll notice this one is the size of what looks to be a staple. You are able to bend these ends if you need to, so not a big deal with whatever spacing you want to use it on. I try and use a properly sized cable for the job, just because I like things to look nice and neat. If you use properly sized cabling, you'll actually get really cool, straight paths across everything, and it just makes your project look a lot better. So I'm going to connect, again, the negative side, or the short side of my LED. So I can plug into any of these holes here, because they're in the same row. And I want to plug that into the negative column over here. And there we go. So while I was pushing that in, I actually moved my LED like that. And now typically this will still be connected in here, but because this is the shorter side and this is the longer side is touching the back of the breadboard, but this wire is up a little bit. So what I always like to do is I like to kind of lean my LEDs a bit to where the short side of the LED is also touching the bottom. So the LED looks like it's leaning a little bit, but I've ensured that both sides are well connected inside the breadboard. At this point, we have built our circuit. We can now hook it up to the board and then hook the board up to power. So what we're going to do is we're going to take our jumper cables here, and notice that the negative is colored black and the positive is colored red. Again, use these things to your advantage. So I'm going to plug in the black wire to the black side. And then I'm going to plug this in to one of these ground pins. There's actually two ground pins here. Negative, at least for the circuits that we're going to be doing, negative is going to refer to ground. So I'm going to plug that into ground. The face of the black part should actually fully seat on top of either the header here or the breadboard. So make sure you've actually pushed it in as far as it can go. You shouldn't have to force anything. It should go in pretty easy. So if you are finding yourself having to force something, there could be something wrong. So while I would not usually, plug something in way down here, I just do want to illustrate the point that this whole column on this positive side here is connected. So I'm going to plug in the red all the way down there. And then because this is positive, we want this to be our positive voltage. I'm going to find my 5-volt pin, and it should be labeled as 5V. V is in Victor. And I'm going to plug in that into 5 volts. So now my red is connected between 5 volts and positive. And then if we were to follow that circuit through, we see it hits a resistor, goes across, goes to a switch, goes to the actual button, comes out this leg, goes through this LED, back down through the negative, and the negative is connected to ground. So we now have a fully closed, complete circuit. And just for completeness, this, I said I would put it down here as an example. It doesn't matter where in this column you put it, but because I like to keep things neat and I like to keep my cable management kind of in check, I like to put these near the top just to keep everything out of the way, because in more complicated circuits, you're going to want to rewire things. You're going to be like, oh, I need to do this instead of that. So it's good to have all your cables on one side. That way you have a better working surface. But because I'm showing you an example, and to really hit the point home about how the breadboard is connected underneath, I'm going to be plugging it in like this. So I have the same cable we used in the initial setup. It has the two ends like this. This end goes to your computer, and and this end goes to your chips. So I'm going to plug those in now. So by plugging this in, it is going to power the chip. You should notice immediately some lights turn on. Notice I'm not touching things with my metal tweezers here because you can actually short out the board here. It's also generally a good idea to not put your finger on things, especially while the board is powered, because you can conduct small voltages, which, while unlikely, could actually damage your board. And that's really the main purpose behind this yellow board, to prevent you from having to touch it. And I actually have this piece of wood here that I've actually cut some holes into to make an even more secure work surface. So now that the board is being powered, again, we're not programming anything today. We're just using it to pull 5 volts and use a ground. Now that we see things are powered, we should actually be able to use the circuit here. So when I press this button, hopefully, hopefully we'll see this LED turn on. So let's try that now. Look at that. LED turns on just fine. I hope that wasn't too bright for the camera. So if I press and hold the button, I complete the circuit, and now if I let go of the button, the circuit is now open and the LED turns off. So we have just built our first circuit, and it didn't take too much doing here. We just used a resistor, a switch, and an LED, and some wire. Really, a lot of these first circuits in these tutorials are going to be this simple. But in the next tutorial, we will actually be programming this. But I get ahead of myself. This is a simple circuit, but at the beginning of the tutorial, I said that we would be making a series circuit and a parallel circuit. So let's do that now, and we're now going to be using our second switch. So first things first, remember, before you start messing around with any circuitry here, always unplug your board. And when the lights turn off, which should be basically immediate, you know that you're good to continue. So first, let's talk about what a series circuit is, and you can actually read more about this on page 28 of your tutorial book. But in brief, a series circuit is just a circuit in which your components are laid out in your circuit into a straight line to where the flow of electricity has to pass through every single component in order to complete the circuit. Technically, we have made a series circuit already. But now we're going to make a series circuit with 2 switches to really bring home the point of what a series circuit means. So let's do that now. What we're going to do first is kill that gnat. Got it. What we're going to do first is we're going to disconnect the LED, and we're going to disconnect this green wire. Again, your wire can be colored anything, it doesn't matter what color it is. A little pair of tweezers is also very handy for pulling components out. Though they do make, if you are interested in mostly using tweezers, let's say you have arthritis or you're just not very good at picking things with your fingers, they make plastic tweezers just for pulling components out of things like a breadboard, and they do it in a way to where it won't damage the components. So maybe I'll find a link to that, an affiliate link below or something if you're interested in that. So now we have just this side of the circuit up to the button. And we're going to go ahead, again, making sure that these legs are on this side of the switch. We're going to place down the switch into the breadboard. I happen to choose a spot 3 spaces away, but again, you could even, oh my gosh. So that's why it's sometimes good to use tweezers, because when you pull components out, these little things can jam up inside of your fingernail, which is not very fun. Anyway, what I was saying is you could actually put this way down here if you so desired. It doesn't matter, but I do like to have a little bit of closeness with my components just so I can see everything. So I'm going to put it up here. Next, we are going to connect the bottom leg of this switch to the top leg of this switch. So I'm going to use another little wire here to connect those two. There we go. And I pressed it all the way down. Now, again, I could have put this even back here if I wanted to, because these rows are all connected. But because I like things easy to see and easier to follow the circuit, I like to place my components as close as possible to each other if I'm very sure I'm not going to need to place another component in between later. Next, we're going to add back our LED. Again, being sure that the longer side of the LED is on the positive side of the circuit. So again, here's our positive, follow it through. So right there should be my positive side of the LED. Notice I did not place the LED to where both legs are in the same row, because you've really just created a short circuit here. So you would actually, after trying to connect something over here, you would find that the electricity, because it wants to go the path of least resistance, would actually just pass underneath the LED. It would never go into these wires here. It would just pass underneath, because again, all these holes are connected, and then continue the circuit from there. So you may think you've hooked up everything correctly, but your LED will not turn on, or will at the very most be extremely dim. So you want to instead make sure you're taking up two different rows. That way each of these wires are on a different connection. And lastly, we do exactly what we did before, and that is connect the negative side of the LED to the negative column, like so. So now we have another complete circuit. We don't have to do anything else with these wires. They're exactly the way that they should be. And I'm now going to power the board, and we will see what happens. So we see here that the board is getting power. Again, I'm being very careful to not touch this with my metal tweezers. I should actually probably get me some of those plastic tweezers too. But we see the circuit's on, and now if I press the button, what do you think is gonna happen? Press. Nothing. What if I press the second button? Press. Nothing again. Have we hooked up something incorrectly? No, we haven't. Because this is a series circuit, remember what I said before, all the components are hooked up in a single line, which means if there is any open connection anywhere in the circuit, the electricity will not flow at all. So because both of these switches are currently open, we don't have to just press one, we have to press both. And as we can see, the light lights up because we have completed the circuit in this series circuit. If I release either button, you can see if the light turns off. And of course, if I release both of them, the light also turns off. So that is what a series circuit is. So you may be wondering at this moment, why in the world would you want a circuit where you have to press two buttons to light something up instead of the first circuit that we had where we only had to press one button? Well, this is merely an example to show what a series circuit is versus the simpler circuit that we had before or the parallel circuit that we were about to build. There are times, especially in computer logic, or hardware logic for that matter, where you will want two things to have to be true or on in order to have a result, where just having one thing be true is not good enough in order to turn something on. So there will be situations where you will do this, but you will likely do them in your microprocessor when we start programming things. For those of you that are used to programming, this would be something like an if-then-else statement, where you would have if something and something else, you get the result. Else, nothing. So now we are ready to tackle the parallel circuit, and then this tutorial is complete. So before I mess around with anything over here, remember to always unplug your board. Basically, if these lights are on, don't touch anything over here. It's just a good general rule. We're actually going to keep both switches in their current positions, but we're going to remove the LED yet again. We're going to remove this wire that connects to the negative terminal, and we are going to remove the wire in between the two switches. So for a parallel circuit, we're going to ideally make a circuit that electricity can flow through one button and into the LED, or flow through the second button and into the LED. And that or is very important because that should mean that at the end, we can press one button or the other and provide power to the LED. This is something a lot more common in use today. For instance, a lot of people in their houses have light switches wired up this way to where any light switch in the room can control the light, and this is actually how they work. So to begin, we actually want to connect up, since this is coming from power, we want to connect this row, which is the top left leg of this switch, to this row, which is the top left leg of this switch. And the reason we want to do that is we want to give the power the option of going through this button or this button. So to do that is pretty simple. We're just going to place a cable which connects those two. I'm using the tweezers just to hopefully make it easier for you to see, but you can just push in there with your fingers. So now we see that power can flow into this row and either continue going into the switch or divert over to this row and go into this switch. So now it's just a matter of really making two of the same circuit that we already have. So to do that, I'm going to go ahead and place in my LED just so I know where I'm aiming. Again, longer side goes on the positive side of the circuit. So I've pointed the positive side this way. Next, I'm going to connect up this leg of this circuit and this leg of this other circuit to connect up with the positive side of the LED, which is the side closest this way. And just a general note, if you're following along exactly with me, just know that in general, I'm not saying I'm always going to do this, but in general, I actually space all my components about 3 holes apart. So if you want to use the same color wires as me, just do the same thing with your components to where there's a gap of 2 holes, and then on the 3rd hole, you place the component. So in that case, the reason I couldn't get that in is that I accidentally went on the other side of the metal down in there. And it's pretty obvious when that happens because you just can't push it down all the way. If that happens, just pull it out and then reseat it, and it should go in very easily, just like it did just there. Next, we're going to take the leg of this switch and connect it also to the positive side of the LED, because again, we want to make essentially 2 circuits here where each circuit goes through the LED. All right, so now we are going to do our final wire, which is connecting the negative side of the LED to the negative column of our power column here. And there we go. So let's review before we plug it in so we know exactly what's happening. Power comes from this column here through the resistor, and now it has a fork in the road. It can either go up through this switch, down into this gray wire, across, up through this LED and out, which will power the LED, or it could go through this wire, which leads it through this switch, which goes through this orange wire, through the LED, and out. So we should be able to press either one of these buttons and light up this LED. So let's go ahead and plug in the board and see what happens. And something that I've just been kind of doing, but I would like to mention, is that I always hold, you know, if I'm pushing this way, I'll hold this side. If I'm pulling out, I'll hold this side. I do that just because I'm going to be using this board a lot, and it's very easy over time to work the board in such a way, if you're not supporting it, that you'll actually start breaking the board. Okay, so yet again, we see that our lights are on, so we know the board is being powered. And so now let's go ahead and test. If I press the first switch, our LED comes on. If I press the second switch, LED also comes on. What do you think happens if I press both switches? Well, let's see. LED comes on. And the reason being is that the electricity is able to flow through either button, which also means that it can flow through both buttons if both buttons are held down. So holding both buttons down is the same thing as only holding one button down, either button, but if you let go of all buttons, then the LED turns off. So what is happening here is that when we hold both switches down, the electricity is going in the path of least resistance. But which is the path of least resistance? And let's not get into the math about, you know, the length of these wires and whatnot. the resistance of either going through this button or going through the other button is basically the same. So you're actually going to have a split in the electrical flow between both buttons. However, if one button, say we wired up a resistor to only be going through this button here. If we wired up a resistor there, more of the electricity would actually go through this button if they're both being held down. So that's just something good to know, that electricity does go through the path of least resistance, but if two paths have the same resistance, they will have the same amount of electrical flow going through them. So that is it. That actually completes tutorial number 1 for the Arduino Starter Kit. Please join me next time for the second tutorial in the Arduino Starter Kit, and also be sure if any concepts such as resistor codes, Ohm's law, anything like that, which I didn't really talk about Ohm's law a lot, but any type of fundamentals like that, I will have those videos uploaded on the channel soon if they're not already, so please be sure to check those out just so you better understand the theory behind electronics. And as always, please like and subscribe, and if you have any suggestions on how I can make these videos better or subjects that you would want me to make videos on, please put them in the comments below. Until next time, see ya.